This presentation introduces a few IP address concepts important for setting up network segments in a network. The speech is AI generated from text. IP addresses allow routers and switches to steer packets as they move around and between networks. When a router receives a packet, it checks its routing table to see where to send it. When a switch receives a packet, it checks its list of connected devices first. If it doesn't find the recipient there, it sends the packet to a gateway address for routing. Messages, that is packets, include both from and to IP addresses. This is an OSI Layer 3 network function. IP addresses consist of 32 binary bits. We call each grouping of 8 bits an octet or byte. Binary values are usually displayed as 4 decimal numbers separated by dots. Each number represents one of the 8-bit octets. So, values range from 0 to 255, and the numbers between the dots in an IP address are never greater than 255. The binary address shown here would be an IP address. People would say 10.0.1.1. The human version is used when we configure network devices. Network ranges are generally expressed as a starting address and a bit count. The starting address indicates the lowest value in the range, while the bit count determines how many leading bits in the address remain constant. Specifying address ranges can get complicated, but here is a simple example. A network segment or switch could be assigned a range of addresses in this form: 10.0.1.0/24. Addresses in that range would all start with the same 24 bits as shown. The last octet could be used to identify a particular device connected to the switch. A maximum of 254 devices could be referenced in this range. A unique device number would start with 10.0.1, and it would have a final number between 1 and 254. That is because the first and last value in the range are reserved for use by the switch. Most network devices use non-routable IP addresses. You may have learned that the Internet Assigned Numbers Authority, the IANA, is in charge of assigning IP addresses around the world. That is true. But in practice, local, non-routable IP addresses are used internally. Non-routable addresses are not viable as Internet addresses. Similar non-routable addresses are used inside millions or even billions of local networks. You might think of non-routable addresses as office numbers in a building used to find the right room on the right floor, rather than as publicly visible street addresses used by Uber drivers. Several hotels in the same city use a room number like 222 to identify a room on the second floor. Similarly, a non-routable address like 10.0.1.1 can be used on multiple internal networks at different organizations. The non-routable ranges are shown. These ranges are used and reused in numerous organizations to manage internal networks. Network segments are assigned IP address ranges to facilitate routing of messages across networks. Dynamic Host Configuration Protocol (DHCP) is provided as a service on network segments so that when a device connects, it can get the information it needs to send and receive messages. DHCP services can perform a variety of functions. Here, we focus on how it assigns IP addresses. The data link layer, Layer 2 in OSI model, uses media access control MAC addresses to send frames to the right place. DHCP and switches keep track of devices based on their MAC addresses. But a message needs an IP address to travel to other network segments or out to the internet. Devices move around, especially wireless devices. For a network to be useful, response packets need to find their way back to the right place. A person may use their laptop at home today and at work tomorrow, but the IP address ranges for the networks it connects to will be different. To work, the laptop needs to be assigned an IP address that is in the range assigned to the attached network segment. That is where DHCP comes in. When a device connects to a network, it provides a MAC address, and DHCP tells it what IP address to use. In most cases, DHCP establishes a lease. It associates an IP addresses from its assigned pool to the MAC address of the device. However, for some devices such as shared devices or administrator machines, keeping a constant IP address can be important. This facilitates consistent access to shared resources and can be a tool for securing privileged access. Instead of creating a lease from its pool, DHCP can be configured to always assign a specified IP address to the same device based on its MAC address. Network administrators both configure IP address ranges to use in the DHCP pool and set up static rules to consistently assign a particular MAC address to a listed MAC address.